Day 72 of doing a LeetCode problem every day until I get a job. All right, guys, we're back again another day, another LeetCode problem. This time we're at day 72. Hope you guys are still motivated and still staying disciplined because we still have a long way to go. We're just getting started for real. So get ready, guys, because we're not stopping anytime soon. So get mentally prepared to just keep going, guys. But before we get started, don't forget, bring your mouse right over here and click that subscribe button for me, guys. Then after you click that subscribe button, go ahead and smash that like button for me, guys. Then after you smash that like button, go ahead into that comment section. I'm calling all of my bankers out there. Go into that comment section and drop that bank emoji in the comment section for me so we can run this engagement up and we could get this page and bring more Swift awareness out to a broader audience and get more people interested in Swift and learning about Swift so we could grow this Swift community, guys. Now, the part you've all been waiting for, the question. And today we have question number 216, combination sum 3. The difficulty level is medium, guys, but you know how we do. We're going to keep the solution as simple and easy to understand as possible so we all can learn. We're all here trying to learn something, and that's going to help us learn keeping the solution easy to understand. Now, with that being said, let's get to the question and see what it says. It says, find all valid combinations of k numbers that sum up to n such that the following conditions are true. Only numbers 1 through nine are used. Each number is used at most once. Return a list of all possible valid combinations. The list must not contain the same combination twice, and the combinations may be returned in any order. So, let's see what they're talking about so we can break it down. The question is really not that difficult to understand once you look at these examples, but let's look at them so we can break it down for people who need a little bit of help. So it says input k equals 3, n equals 7. So what we want to do is find all the combinations of numbers 1 through 9 that we could put together to add up to 7. So that's why the output right here is 1, 2, and 4 because 1 plus 2 plus 4 equals 7, and there's 3 numbers. So k gives us how many numbers we're allowed to use, and 7 gives us the target that we're trying to reach after all the combinations. So if you look at the explanation, it says 1 plus 2 plus 4 equals 7. There are no other valid combinations, meaning where we use 3 numbers. There are no other valid combinations where we could use 3 numbers that equal 7. So that's the only array that we need to return. Let's look at example 2 because it's a little bit more complicated and there's more combinations than just one. So in this case, k equals 3, so we need 3 numbers, and n equals 9. So we need all combinations of 3 numbers that add up to a sum of 9. So that's why the output here is we have the list of those three combinations, right? But there's only 3 combinations. Don't get the 3 combinations confused with this 3. This 3 represents how many numbers are allowed in each combination. It just happens to be that there are 3 different combinations in this output. So, excuse me, guys, in this output right here. So let's break it down. So the first one is 1 plus 2 plus 6, that equals 9. Then we have 1 plus 3 plus 5, that equals 9. And 2 plus 3 plus 4 equals 9 as well. And the explanation says the same thing, and just so you know, that's where those 3 combinations come from and why we are using those. And then after those 3 combinations, there are no other valid combinations. So let's look at example 3 just for in case they try to throw a little trick question in there for us where the input is k equals 4 and n equals 1. In this case, we just the output would just be a blank array because there are no valid combinations. Using 4 different numbers in the range 1 through 9, the smallest sum we could get is 1 plus 2 plus 3 plus 4 equals 10. And since 10 is greater than 1, there are no valid combinations. So let's see how we're going to solve this, guys. It's not that difficult, but it's a little bit of code. So just just know we're going to have to do some coding here. It's not too much code, but it's going to be a little bit. But the first thing we're going to do is we're going to create a private function, which is going to be our helper function. So we're going to just create a private function. We're going to call that help, and the help is going to have an index, and that index is going to be an integer. Then we're going to have another parameter called k, and that's going to be an integer. Then we're going to have another parameter called n, and that's going to be another integer. Then we're going to have another parameter. We're going to call this temp, and that is going to be an in-out array of integers. Then we are going to have another parameter. This is the last parameter though, guys, and that's going to be called result, and that is also going to be an in-out, but this time it's going to be in-out to the array. So it's going to be an array inside of an array of integers. Excuse me, guys. Gotta check this for typos. Make sure the typos are good, and we're good. So let's keep moving. Then after that, we're going to come down here and we are going to say if n is equal to 0 and k is equal to 0, then what we are going to do is we're going to take the result. We're going to say result.append temp. Then we're going to come underneath that and we are going to just return. Then we're going to come underneath that if statement right there. We're going to create another if statement, and that is going to be, we're going to say if k is equal to 0. This time we're going to say or n is equal to 0. Then we are going to just return. Then we are going to come underneath that if statement, and we are going to say for I in index up to 10, because we're only working with numbers 1 through 10. We're going to say if n is greater than or equal to I, then what we are going to do is we're going to say temp.append I. Then we're going to come underneath that and we're going to do a little recursion. We're going to call this help function, and we're going to say help. We're going to open up the parentheses. We're going to say I plus 1. Then we're going to come over here. We're going to say k minus 1. Then we're going to come over here. We're going to say n minus I. Then we're going to come over here and we're going to say and temp. Then we're going to come over here and we're going to say and result. Then after we do all that, we're going to come underneath that one more time and we're going to say temp.remove last. Then we're going to come up here to the original function. We're going to declare a variable called result, and we're going to set that equal to a 2D array of integers. Then we're going to come underneath that. We're going to declare another variable called temp, and we'll set that equal to an array of integers. Come on, don't forget the parentheses. Then we're going to call the function help that we just created, and we're going to say, open up the parentheses, we're going to say 1k n, don't forget the commas, comma n, comma, and temp, comma, and result. Then we're going to come underneath all of that and we're just going to return the result. So let's run this, guys, see how it runs. Hopefully it runs well. Fingers crossed, guys. Let's see. And it's accepted. That's what I'm talking about. So let's submit it and see if it stays accepted after we submit it, because sometimes you'll run it and it'll be accepted, but not when you submit it. But it is this time. It's accepted with 2 milliseconds and it beats 73.68% of users with Swift, guys. So that's not too bad at all. So hope you guys learned something today. Get one more look at the code, and I will see you guys tomorrow for another day, another LeetCode problem. Peace.